Okay, so in this question, we've been presented with this equation and we've been asked to balance it. So what do we actually have? In this specific question, we've got FeS, right, which is iron 2 sulfide, which reacts with oxygen that produces, well, we've got 3 oxygen, so this is iron 3 oxide, and at the end here we've got basically sulfur dioxide, right? And we've been asked to balance this, so we need to do that, and in our final balanced equation we need to use only whole numbers, right? So how am I going to approach this? Well, the first step I'm going to take is I'm going to try and really audit how many occurrences are there of each element on the reactant side, so on the left hand side of the equation, and I'm going to do the same on the product side. So I'm going to do the same on the right hand side of the equation, right? So in this particular case, you've got iron, we've got sulfur, we've got oxygen, right? So, and I'm going to use an abbreviation. I'm just going to write left hand side. So left hand side, we've got iron, right, sulfur and oxygen, right? Similarly, on the right hand side, you can just write that we've got iron, sulfur and oxygen, right? So how many occurrences do we have on each side? So let's start with the left hand side and just go through. So iron, as you can see, only occurs in this species, the FeS, and it's once, right? Similarly for sulfur, it only occurs in this species, it's going to be 1, and O2 for oxygen, we've got it occurring effectively twice, right? Now let's take our attention now to the right hand side. So here we can see iron is Fe2, so it's going to be 2, and then the S, so we've got SO2, so it's going to be 1, and then oxygen we've got O times 3, which is well, it's 3, and then O2, so 3 plus 5, 3 plus 2, that will give us 5, right? Now at this stage, what we also need to do is, well, let's actually take a look at the results. So what can we see? Well, what we can see is that although the sulfur seems to be balanced, the iron is clearly not. We've got 1 on one side, 2 on the other side. Oxygen is not balanced either. So we do have to give some consideration to how we can take a step which would hopefully progress this equation towards being more balanced, right? And so we can kind of, in a sense, pick between, well, do we want to focus on the oxygen first, or do we want to focus on the iron first in terms of balancing? Now, if we bring our attention to the actual equation itself, it would make more sense to focus first on the iron, specifically because, as you can see in the equation, it occurs in a form where it's not on its own, right? You've got FeS, whereas oxygen in the equation does occur on its own. It's much easier to tweak the oxygen towards the very end versus any other element present, right? So we'll leave oxygen for now, and I'll focus on the iron because of that, right? So what I'm going to do is I'm going to put a 2 in front of the iron 2 sulfide. Okay, so if I do that, and I'm going to write out what the new equation we're going to get. So we're going to get 2 FeS plus O2, that produces Fe₂O₃ plus SO₂, right? Now, if we do our process of kind of auditing this for the elements again, we can do the left hand side first. So FeS O, and so we added a 2 here, right? So that's going to mean that we've got, for Fe we're going to have a 2, for sulfur we're going to have a 2, right? Now for oxygen it just occurs here twice, right? So we're going to have a 2 there. And in terms of the right hand side, we didn't do anything, right? We didn't change anything. So because that is simply the same as it was originally, we can literally just use the values that we already had determined. So as an Fe is going to be 2, sulfur is going to be 1, and oxygen is just simply going to be what it was before. It's going to be 5. Okay. But what can we see here now? Well, as you can see at this stage, the iron is more balanced, right? Right, you've got the equal number of iron on both sides, but the sulfur is not, and the oxygen is not. As I said, oxygen is on its own. Because it's on its own, I'm going to leave it for now. I'm going to focus on those ones which are not on it. So sulfur is not on its own, right? In both cases. So I'm going to focus my attention on the sulfur, and I'm going to put a 2 in front of the SO2 on the right hand side. Okay, so this SO2 here, I'm going to effectively put a 2 in front of it. And so if we do that, I'm going to write out what the new equation is going to look like, right? So 2 FeS plus O2. So we didn't change anything on this side, right? That's then going to produce Fe₂O₃ plus, and then we're going to put a 2 here, right? As we agreed, 2 SO2. Okay. And so now, if we do our process again, auditing this, what do we find? Well, for the left hand side, we didn't modify anything in this. If you look, it's the same as what we had. It's the same as what we had earlier on. We didn't modify anything. So for that aspect, like the left hand side, it's going to be the same. It's going to be just Fe2 S2O2. Okay, nothing changes on that side for now. On the right hand side, we've added 2 SeO2 here, but as far as iron goes, it's not been affected by that change because it's over here. So for the iron, it's just going to be the same count of 2, right? For sulfur, on the other hand, we've put a 2 in front of the SO2, so this gets multiplied by 2, right? So we've got 2 times this, so it's going to be 2. And for oxygen, now oxygen here actually occurs both, right? We see it occurs in the Fe₂O₃. It also occurs over here. So we've got 2 times 2, which would be 4, plus the occurrence here, which gives us 7, right? Right. So as we can see now, more or less, we've got the iron balanced, the sulfur balanced, but the oxygen is not balanced, right? We've got 2 on the left hand side, and we have 7 on the right hand side. So conveniently, as mentioned right from the start, oxygen is on its own, and so we intentionally left it to the end because it's much easier to modify the oxygen without affecting other elements. So it's quite a good one to leave on to the very end, right? So what do we actually need to do to change the oxygen on the left hand side to be on par with the oxygen on the right hand side? It should be quite clear what the scale factor is, but to make it more clear, we can just divide the right hand side by the left hand side. So if we do 7 divided by 2, that's going to be 3.5, right? So we need to scale the left hand side oxygen up by 3.5 in order to get it on par with what's on the right hand side. So this is what I'm going to do. I'm going to put a 3.5 in front of the O2, okay, to try and get this to be balanced. 2 FeS plus 3.5 O2, that goes to produce Fe₂O₃ plus 2 SO₂. Okay. Now, if we then give consideration to both sides again, so left hand side and right hand side, right? So in this particular iteration, as you can see, we did not modify anything on the right hand side just now. So the outcome as far as the as far as the auditing is literally going to be the same as it was before, right? So we can just quickly do that. So that's going to just be 2, it's going to be 2, that's going to be 7, right? So but on the left hand side, we've added the 3.5, so let's take a look at what we're actually going to get. FeS O, right? So for iron, we didn't change what's in front of the iron here, so FeS is more or less the same thing, right? So 2 times Fe, right? So it's going to be 2. Sulfur only occurs in the species of the iron 2 sulfide, so it's going to be 2. And for oxygen, we've got the 3.5, so 3.5 times 2, which we know to be 7, right? So if we look now at the left hand side and the right hand side, we can see that in some sense it is balanced, right? We've got the same number of occurrences on both sides. However, we're not quite done with this question, and that's specifically because of what we've been asked to do in the question itself. The question specifies that please use only whole numbers when balancing the equation above, right? So when we're actually putting our numbers here, we've been asked to use only whole numbers. We haven't quite met that particular requirement yet, even though we quote unquote seem to have a balanced equation. But the fix is quite straightforward, isn't it? All we need to do is double everything, right? I mean, we're really trying to get rid of this, but in order to get rid of it, a seamless way or straightforward way to do that is to just double everything. That way we go from 3.5 to 7, and everything else as well. We get well, we have to double it. So and this is simply based on the principle that whatever you do to one side, we need to do it to the other side as well, right? So in order to keep everything balanced. So if we do that, what are we going to get? So I'm going to now go through the new equation we get when we go through that process, which is going to be effectively 4. So I'm literally just doubling every coefficient, and where there is no coefficient, we assume the coefficient is obviously 1, so we double 1, which is going to give us 2, right? So FeS plus, and in this case double the 3.5, so we're going to get 7 O2. And here, as I said, like, we don't have a coefficient visible, but we, reasonably, it's assumed to be 1, of course. So we're going to put 2, right? So Fe₂O₃, and then here we have a coefficient of 2, so that's going to be, instead it's going to be 4 SO2, okay? And of course, the effect that would have, if we've done this correctly, is it's going to lead to a doubling of all of these values, right? So, but I'm going to actually go through it carefully just to make sure. So and then similar here, we've got right hand side, we've got Fe SO, right? Okay, so on the left hand side, we've got 4Fe, right? So that's going to be 4 here. 4S, right? So that's going to be a 4. And then 7 times the O2, so that's going to be 14, isn't it? Right. Now, if we now bring our attention to the right hand side, so for Fe, we've got it occurring here. So 2 times Fe2, so that's going to be 4. For sulfur, we've got 4SO2, right? So 4 times S, that's going to be 4. And so for oxygen here, we have 2 times O3, which is going to give us 6, right? So 2 times 3 is 6. And we've got 4 times 2 on this side, which is going to give us 8. So it's effectively 6 plus 8, right? Which is going to give us, of course, it's going to give us 14, right? And as you can see, this is balanced, right? And it also meets the requirement of being whole numbers used only. So in this particular question, this would actually be now this would be our balanced equation, right? So it's going to be so for our question, we can say, well, if we put 4, 7, 2, 4, would give us our balanced formula, right? Okay,